So let's take a look at other criteria to evaluate the model. So can you think of any other performance metrics besides accuracy? Precision, yeah, that's perfect. Kayla, can you elaborate a little on what precision is?
Sorry, yeah. It's like accuracy is more like how correct things are, whereas precision is more like um where things are in relation like to each other.
Okay, that's a pretty good, and we'll take a look at the exact definition in a couple of slides. But yes, that's perfect. Anybody else? So let's say, let me ask you a question. Let's say that I have a COVID test, okay, which has pretty good accuracy. But for the ones that have COVID, it usually makes mistakes and tells people that they don't have COVID. Is that a good test or not really?
Wouldn't that test not have good accuracy then?
No, because fewer people have COVID than the people that don't have COVID, right? So
Oh, yeah.
let's say I have a thousand patients, okay, and only 10 of them have COVID, which is more like a very realistic case, right? And let's say out of those 1,000, for the 990 that don't have COVID, let's say it tells 950 that they don't have COVID. So it gets 950 of those correct. And then for the 10 that do have COVID, it only gets 50% right. So there's only 5 patients that that it gets correct. So then that's what, 955 out of 1,000. So that's pretty good accuracy, right? Of 0.955. But for the people that have COVID, it's only going to be right 50% of the time. Is that a good test? Also, Matthew had this happen to him. Yeah, so it doesn't sound like a good test, right? But it does have good accuracy. And so we're going to take a look at other measures of performance besides accuracy, because accuracy can be misleading or can be can ignore some of the cases that are really important. All right, so we're gonna take a look at, there's like many of these metrics. There's gonna be some formulas, and I'll be going through all of these metrics. Don't worry if you don't follow exactly each of them. You'll have the slides. Just try to follow and definitely ask me what the logic behind, like, and the motivation behind why we take a look at these metrics. So there's false positives, okay, true positives. So who can tell me what the difference is?
A false positive is when you're actually negative, but it says you're positive, and true positive is when it says it's positive and you are positive.
Awesome. Perfect. Yeah, that's exactly right. So let's think of COVID, which unfortunately, I think we all have it close to our hearts right now. So false positive means that I don't have COVID and the test comes out positive, right? And then true positive is I do have COVID and the test does come out positive. So true positive, great. False positive, not so great. Okay. But in this specific example, what's much worse is a false negative, right? Which tells me I don't have COVID, but I really do. And so I get on a plane and spread it to everyone around me. Okay. And true negative is I don't have COVID and the test comes out negative, which is great. So true positive and true negatives will go towards like accuracy, right? And false positive and false negatives, like I will increase the accuracy, and false positives and false negatives are just errors made by the model, okay? And so with those four, we can construct metrics such as sensitivity, specificity, positive and negative predictive values, and others, which we'll see. All right. So something I always find very intuitive and helpful, because these like sensitivity, specificity, recall, etc., precision can get a little confusing. But ironically, the confusion matrix, which talks about the confusion of the model, not of you, I find that is very intuitive. So what we're gonna do here is, on the columns, we're gonna take a look at the actual truth. Okay, so the ground truth, the data. So observed positive is, let's stick with the COVID example, is everyone that does have COVID will be in column 1. And then observed negative is everyone that doesn't have COVID, which will be in column 2. Okay. And then we have our model. And so out of everyone that does have COVID, which is in column 1, the model will predict some of them positive, some of them correctly, which are the true positives, and some of them incorrectly, but they do have COVID, right? So these are the false negatives, okay? And then same for the observed negative. So for the ones that don't have COVID, the model will predict positive for some. So the first row will be the positive predicted ones. Just the positive predictive ones will be correct in the first column and incorrect in the second column. And then the negative predictive ones will be incorrect in the first column because they do have COVID, and correct in the second column because they don't have COVID. Okay, so rows are the ground truth, and columns are the ground truth, and rows are the predictive values. And so these diagonal values, or off diagonal, are the correct ones. So if I wanted to compute accuracy, I would just add up these two values and divide by all of the sample, right? All right. So when do we care more about false positives? Like, what scenario can you think of? Is this a COVID scenario?
We probably care about false positives because if something is true positive, that means that it's actually accurate and it's telling the truth. But if it's something that's false positive, it's an outlier, and you have to like correct it before it gets out of hand a little more.
Right. But so let's try to think about a scenario where like a false positive is actually worse than a false negative. So when could that happen?
I guess if you were like inspecting something, like maybe like a car inspection, if they say it's fine, but it's actually not, kind of thing.
Yeah, definitely, right? Because if it's not fine and I get into the car, maybe the brakes don't work and I can get into an accident. Or maybe a false positive is for these, like going back to fairness, these algorithms that will predict whether someone can get out on bail, or if they will like commit another crime or try to escape. Like, let's say I'm predicting if someone is trying to escape, and so it's really bad if I have a high false positive rate, right? Because that means that I'm keeping people in jail that should not be there. Okay, so any costly intervention or risky like scenario like the car will be places where we really care about false positives, right? And so here, for example, predicting an invasive medical procedure. Let's say that I have a model that predicts a disease, and if you do have that disease, then you need to get surgery. And so then a false positive would be really bad, right? Because I would get surgery even if if I'm predictive false positive, I would get the surgery without needing it, which is a pretty bad scenario. All right. When do we care more about false negatives?
when it can lead to like further spread of disease.